Today, I'm going to show you how to measure lateral runout on a front brake rotor. I have the car in the air, I have the wheel removed, I left the brake caliper and brake pads in place. So just up in the air, remove the wheel, this is what I'm looking at. As you can see here, I'm going to move the brake rotor back and forth, it's quite loose. The car's wheel and the lug nuts normally hold that brake rotor in place. But with the wheel off, I need to do that myself. So here I have a couple stacks of washers. I got two sets right next to each other on two lug nut studs and one across from it. And I'm going to use these stack of washers and these lug nuts to tighten this rotor down, just to hold it in place while I make my measurements. It doesn't have to be real tight, and I just have a little stubby combination wrench that fits the lug nut. I'm just using that to tighten it up. It really doesn't need to be much. Definitely not an impact. Just need to snug it up just a little bit. Once the car is set, we need to get the tool out. And the tool has a few pieces. The first one here is this black snake. The end of which I have in my hand there is going to hold the dial indicator. It doesn't need to come apart, but it should fit together so the concave and the flat pieces go together correctly. You have a little thumb screw you can use to adjust it. What I'm pointing at there, that little nut, that needs to thread down to tighten the snake up. So when you turn the little red lever, it makes the snake stiffen up so it can be held in place to make the measurement. So that little red lever is on a cam, so you turn the lever and it frees up the snake. And then when you tighten up the cam, it holds it in place. So you can put the dial indicator wherever you want. The other part of the tool is the vice grips. Where I have my right hand is a little thumb screw you can use to adjust the jaws open or closed. And then the handle on the left side of it, that opens and closes the jaws so you can squeeze it onto the nut that you want to hold it to. I have it set up here on the upper control arm nut. Right there on the end of the arrow, the vice grips are holding it right onto that nut. It's very firm. Then I have the snake on the bottom screwed into the vice grip on the top, just in one of those threaded holes. Another good location for it is on the steering knuckle. So the top arrow is pointing at the knuckle. Bottom arrow is the vice grip that's attached right to it. A third location here is on the outer tie rod ends nut. And in this location, I'm showing you what not to do. Here I have it actually on the tie rod end. The previous location was the arrow, but now I have it actually on the tie rod. Okay, that's the outer tie rod there. Now when I move the vice grips back and forth, you can see that's really loose and you can't make a proper measurement with it clamped onto that tie rod end. Here on the left side of the screen I have a red box. That's just around the snake, the part that holds the dial indicator. Again, normally those parts do not come apart, but if someone takes them apart, this is the order that they go in. On the right side of the screen is the dial indicator and the snake. The snake attaches to the dial indicator right where the green arrow is, and only where the green arrow is located. The red arrow on the right, that's the plunger that needs to go in and out of that dial. So any distortion of that will wreck the tool. So you definitely don't want to clamp onto that movable needle. Another way that I see it hooked up in the lab is like this here, where we take the the snake apart, and hook it to the dial indicator with a thumb screw. You don't need to do that. That's not a very effective way to hold it, and that just doesn't need to be done. So yeah, definitely don't do it that way. Once I get the vice grips on, the dial indicator in, and the snake tightened up, I'm ready to make some measurements. Here I have the tool set up. So I have a little bit of the plunger sticking out of both sides of the dial indicator so I can get the full range of my movement. So that's one way to know you have it set up correctly. The other way is going to be, is the dial indicator perpendicular to the rotor? It should be as straight as possible, straight onto that rotor. Any deviation from that is going to affect your readings. Now, on the dial indicator itself, I have this red arrow that I'm going to use to make my measurements. I don't want that red arrow to be anywhere near the 0. So right now it's between 30 and 40. When the dial indicator moves back and forth, I'm going to use a mathematical formula called subtraction to come up with our lateral runout measurement. But if the needle goes over the number 0, that doesn't work out. So I'm going to turn the rotor a few times and just see what my highest number, the biggest number, and the smallest number are. And you can see I've already turned it 1 revolution and got up to 81 thousandths. And I'm just going to do this a few times just to make sure I get nice, accurate measurements. So there, the high spot was 81 thousandths. I'm going to turn it back down here. I'm going to go right to 25 thousandths. So high side 81 thousandths, low side 25 thousandths. I make notes of those numbers, and then I'm going to put it into my mathematical formula. Again, simply subtraction. When you're getting customers' estimates and you're making decisions based off numbers, you want to be accurate. So you can use your calculator for this, and I'm just using my phone, which is fine. I'm going to type in my big number, 81 thousandths. I'm going to subtract that from my small number, and in this case it was 25 thousandths. And that's going to give us our lateral runout for this car, which is 56 thousandths, which is probably 54 thousandths too many. I mean, that's a really actually huge number. That big number could be caused by damage to the hub or dirt on the hub. So these two pictures here are the same hub. One is from the side view and one's from a front or rear view. But the picture on the left, any dirt or rust on that location will cause the rotor to have lateral runout. And then the arrow on the right is the same wheel bearing, but if that flange is bent, maybe a customer hit a curb and bent it, that will cause a lateral runout, in addition to a faulty rotor. So for today, your learning target is to measure lateral runout, plus or minus 5 thousandths, write the readings, describe how they compare to specifications, and do it in 10 minutes or less. So that's what you're shooting for today. Set up the snake, whole thing by yourself. You should also be able to answer these questions, which are in your course packet. The questions are in bold, the answers are in light, and you can practice and should practice asking each other these questions while you're watching your partners and helping them with the task. And that's it. I'm sure you'll get it, but if you need some help, come see me and I'll be glad to help you.